Okay, so drafting is important, yada yada. Drafting is more about communicating than it is about 3D modeling or using a computer, but yada yada. So, what is drafting exactly? It's seeing 3D objects in 2D space. This is the way that in theater we communicate as a vocabulary of things. For 3D objects, we have to put them onto paper so other people can see them and other people can understand them. And so we translate our things in our imagination or things that we find in our research into 2D objects. So how do we describe those 3D objects in 2D space? To describe any object, you need a minimum of front plan and side, front plan, side, and section. So what I mean by that is this side view, you could do a side or you could do a section, a slice view, but you need a plan view and you need a front view. The front, side, or section and a top view is what is needed to get the full effect of any given object. Now, when I say that's a minimum, I mean it's a minimum because you can have a lot more views. You could have a top view or a plan view. Those are two different things. You can have a bottom view or a plan view. That's also different things. Left side, right side, section, back, and front are all of the different kinds of things that you can have. And you can think of them as a box that you put around any object. And a picture or of each single one of those sides flattened, that's often what we call a projection, is how you can really see an object from all those sides. A plan view is not a bird's eye view and it's not a worm's eye view. So what do I mean by that? It's not a top view. It's not as if you're flying over this building and seeing the roof. It is not a worm's eye view as if you were in the ground seeing the footprint and only the footprint of the building. If you take the footprint of our design room, you only get where the legs of the chairs touch the floor and the legs of the tables touch the floor. And it's very hard to tell what thing is where. So instead, you get a plan view. And a plan view is a very specific type of view that is more about cutting the room in the most interesting way possible. A section cuts it vertically and cuts it open a little bit like a dollhouse, where your front elevations show detailed views of exactly how the building and the patterns on the building look. Especially for a designer's elevation, your front view is supposed to have a good representation of what your item is supposed to look like, showing where the dimension needs to be built into that item, showing all sorts of those things. The same way that if you're doing a light plot, you need to put every individual lighting instrument into your drafting. You need to have every single item specified, and the elevation view is how we do that. So when we're talking about the grammar of these things, part of what we're talking about is that you're going to have line weight distinguishing the importance of a piece. So as you can see here, this room is described here and you can see it at an angle. And for a ground plan, we tend to cut something at the most useful place. And in this case, and usually, the most useful place is about 4 feet off the ground. That's what we consider, unless there's something other that's interesting, and then we also include that. But I digress. I say that because it's not always effective to just do 4 feet, but 4 feet is the usual thing that we use. And the darker lines show more importance. So you can see in this image here, the darker lines show where this wall is cut through, and you can see an opening that you can pass through here. And you can see a window that you can't pass through, but those lines are much lighter. And they're lighter because they're what you're seeing as the underside of the windowsill, not the wall coming through. So anytime I'm talking about cake, I talk about this as like slicing a cake. So if there's a big open void in the middle of your cake, or if there's a post or something, then when you slice through, you get thickness where there is cake and air where there is not. And if there's air right here in this line, you're still going to see the cake board underneath, or you're going to see the last layer of cake you could see before you see the cut interior of the cake around it. So line weight is really effective in helping us to see where the room is cut and where there is open space. And it's really just effective to see information faster. This is 2 drawings where one just clearly has information that you can see faster. Line weight also denotes for us if there is a surface underneath, an edge, something like that. So when this little eye symbol, if we're looking down at that piece or at a ground plan or somewhere, if there's a change in plane, there is a line. So if there's a bump or change or slope, a solid line tells us that we're changing plane. If we have something that is underneath or hidden, we'll dash that line to let you know that I want you to see that there's something under there, but it's represented in a different way. And so this is kind of how drafting becomes its own language. Dotted lines mean either something is in an alternate position, hidden above or hidden below, but not generally visible, but we want you to know that it's there. So if you have a chandelier or a ceiling art piece, like you're gonna have that as a dotted line or a dashed line to make it more visible and understandable. And it's those conventions that really help us to communicate. Circles are like hyperlink style markers. So circles contain in them usually a letter or number, and they tell us what elevation to go look at. Hatching is usually what is done for a type of material. So in actual architectural drafting, there is a different hatch in the middle of each of those colors or each of those lines. And sometimes they are different colors and they mark the type of material that a wall is made of. So in our drafting, we often have diagonal hatches, which mean brick, because our building is made of brick or cinder block. And those usually come in the drafting that a theater gives you. And inside your actual document, you can note that as being a shaded box or a solid box, or you can hatch that box. And what that means is that something has been cut through, and it indicates even more clearly than just line weight that there is the center of the cake in that drawing. Dimensional hierarchy is that smaller dimensions are closer to objects and dimensions are often nested into each other. So when we're drawing and adding dimensions to things, we are putting those things lined up and easy to read. And you'll see some examples of that later. So when we talk about orthographic views, we're talking about projecting through this screen, like a picture plane. So if you're looking at a line of sight and you're looking at an object, what happens is that you get one flat surface if that item is flat to you. If the item is tilted, that's when we start to get perspective and we start to see items in a different way. So for drafting, instead of having this complicated version of perspective, we are slicing our pieces down to the simplest level of isometric and isographic views, meaning that we're not putting perspective into this drawing. We're doing it as flat as possible so that we can see specific front, side, and back and top plan views, and that every object has the context of all these different images exactly as they would be as if we're picking them up and looking at them for information. On the ground plan and the section view, we will often do the squished version of this. So this or this, where you have a view of that object, but it's not true to size. The elevation is where you can guarantee that that's true to size. So when you're looking at those projections, they are the flattest version of each side view, whether it's front, side, or plan. And it's only with all of those things that you can tell that this box here is a cylinder and not just a square. Because from the front view, the cylinder looks like a square because that's what it would look like straight from the front view. The same with the side view. So it's the plan view that gives us the information that the circular part of this object is circular. Many people include this isometric view, this kind of up and to the side view of a three-dimensional object to help understand what an object is. And if you've created your drafting in SketchUp or another 3D modeling program or made it three-dimensional in either Vectorworks or AutoCAD, then absolutely include the isometric view. But it isn't something that is standard on all drafting. It is very helpful for anyone, but if you're not already in that medium, it can be a lot of extra work to make that additional drawing. When we're putting these objects together, we're also lining them up in a very specific way. So we're always taking it and we're putting the front view over the plan view, and then the right side view and the left side view next to it. So the way that this is configured is if you take that object and imagine that you're unwrapping the box that this object has projected on all sides of that item. So back to that projection of the little house. So if we unwrap that, it shows us that you want the front with the plan view on the bottom, the front with the plan view on the bottom, and all of these sides lined up. And if you need a top, you can put it at the top. But this is a convention of orientation. And we use that when we put our packets together. So the theatrical drafting conventions asks us to have all of the following: the unit elevations, details of each unit alone that we pick up and look at, the ground plan, everything in context, and the centerline section, which is a cut through the center, splitting it open, and everything all together. So those all together ones, those are the ones that include masking and furniture, and they don't have a front view and a side view necessarily. The centerline view is the side view. The ground plan view is the plan view. So we usually have those to make sure we can see how stuff is going to move through the entire show. And the elevations are so that you can pick out any individual piece and really get to know that one item that needs to be built. So the ground plan view or the plan view, like I said, is not a bird's eye view and not a worm's eye view. And we kind of cut it horizontally at 4 feet. So all items on the cut line are denoted with thick lines. So what I mean by that is we take this room and we go ahead and slice it with a chainsaw and open it up. And we have to make decisions. So like this staircase here, it doesn't really make sense to cut that and make all of those little pieces a thick outline and make it look like there's cake there. There doesn't need to be cake there. There doesn't need to be a solid fill, because we can go ahead and do that as a plan view and do that with a little bit of discretion. So when we draw that ground plan view, you have the walls are nice and thick and are being shown, and you can see where they start and where they end. All of the detail in the main structure is then thinner. So we see the top of this platform, so that is thinner. We see the staircase and the platform edges are thinner than where the room itself is cut through. And then you also see all of the dimensions that are in even thinner lines. So these X's on top of the platforms indicate that there are platforms and not just a rug on the floor or a table, but rather that it's supportable for someone to stand and walk on. And that is done in the dimension line weight. And you can see these light lines here that give dimensions are created lighter so that it's easier for you to see and understand where the walls are and not be distracted by those lines. So all the things that are above the dash line or hidden below objects, all of the things above the cut line or below the objects are then dashed. So that's these items here that are dashed, the window, the archway, the bookcase, this window here, this doorway here. And there are always exceptions that you can have. So you can see on that ground plan how all of those things are translated, which are translated the same for sections and when you break out your elevations. But sometimes you are trying to convey something specific, so you need to draft it a little bit differently or use a different color. And usually you just notate that and you're able to make some exceptions. If you take that same set and slice it down the middle and open it that way, that's a section. So sections often look a little bit differently because they don't just slice the set itself, they slice the whole theater. So this is not the same set design, but the set itself is only right here. Everything else is the building. So you've got all of the audience, all of the lighting positions, and this is so that the lighting designer can really calculate if they put a light here, what is the distance to where they have to hit people? What will the brightness of that light be? What is happening? So the section where this slices and slides open like a dollhouse is a really important part of the drafting, but it is also kind of hard to understand sometimes. But essentially when you're looking at it in an isometric view, this is the idea of the interior of the cake. If this whole object was made of cake and there was an empty void moving through the center of it, you need to identify that. Otherwise you can't tell if this is a solid cake or not. So when you cut through the middle of it, you get to see all of those things. So we do that with the set and any piece that needs it. If you're drafting something via elevation and you choose to do a side instead of a section, the assumption is that there's nothing interesting on the inside of that piece. You can assume and build it however you like. So if there is something important on the inside of that piece, then you need to draft a section and not a side view. When you do draft a section view or the overall section, you're cutting through it vertically in order to give height information and interior information. It also, the centerline section is important for seeing any hanging items and, like we talked about, understanding angles for the lighting designer. It does give the director and the technical director spatial understanding and how pieces fit together, but the lighting designer is someone who really benefits from the centerline section and can help collaborate with you if you provide it for them in a timely manner. The elevations are a flat view, which can be any side, but must include at least the front, the side, and a plan view. But you can include top, bottom, left, right, whatever you need. The assumption is that if you see it, you need to draw it. If the audience sees it, you need to draw it. This includes dimensioning all of those people and including a person, because all of our drawings are to scale, and the elevations in particular are about seeing each piece in their scale and orientation. So you want to have a person on every drafting plate next to an individual to help someone understand scale quickly. The drafting plate of elevations should include at least the front, side or section, and the plan view, as I mentioned before, but can include more. And extended elevations are where you connect flats and flatten them together. So what do I mean by that? So this is another example of a very pretty drawing. The plan view is off the bottom of the screen, but this gives you a great idea of the front view and the side view and how this works to have something that's very attractive and detailed that includes some hand-drawn features, but it is all about the specifics. You can also see the nested dimensions I was talking about. So in order to dimension something like this, you usually evenly space them. So you can see this all feels very orderly. And you have a line coming off, and then you are doing your smaller lines inside your bigger ones. So here you've got 1'6", 2'6", 1 foot, 9 inches, all of those coming together. And then there are bigger spots that are dimensioned for clarification, like this little piece juts out in the back. So by dimensioning it differently, it helps you to see that that is different and how that is working. And if anything lines up, we assume that that's the same. So this 11-foot awning does not have to be dimensioned on both sides, because the assumption it is the same because the pictures are right next to each other and lined up correctly. So when you're looking at those drafting elevations, you can also create isometric or axonometric points of view, but you want to keep them without perspective. Extended elevations look something like this. So this is a set design I did for Little Shop of Horrors, and this is combining the walls together so that you could see what the whole room looked like when these pieces are next to each other. It also was the inside and outside of the shop. So I included the flip side of both pieces so that you could understand what these things look like once they were all composed together. I also broke each of these pieces out and continued later, but here you can also see the labels that are circles with letters and numbers in them, which serve a little bit like, I think of them as like hyperlinks. I wish I could actually click on them, but it basically, like, I want to know about this. I need to go to the area of my drafting that says H1 and says specifically what that is, and it will tell me all about that wall. This is a little bit more of that drafting. The A wall is a portal. And here you can see that I've got the plan view, the front view, and the side and section view. Sorry, the side view is over here, the section view is over here. But I included both side and section because I thought it was important. It's hard to see how the shape of this steps up, so I needed both a section view and a side view to describe that adequately. I also wanted to share that this is made with consistent measurements. So I created this little circle and then pulled it out where I put each of those dimensions inside. This is another example of, I think this will make it clearer, so I'm going to do it. The same here. These little sections that I pulled out are slices here, here, and here. And as long as you label them correctly, then people are going to know exactly what you're talking about. I also tend to use color. So I've shown you that I use red for furniture, but I also use blue because it's eye-catching for any changes that are made. Change is part of our process. So when we turn in drafting for final draftings or prelims or anywhere in there and the director requests a change, or through the budgeting process, we need to change something in order to accommodate a change in the budget or anything that could be happening. We are often updating that drafting. So if I update that drafting, I don't want to bury the change that's in there. I want it to be obvious what has changed. So I just change the color of whatever has happened to blue and note that in the notes. And it really helps it to stand out. What do all these plates and drawings have on them? So every time you make a drawing, you have to have the object in which you're drawing, but there's actually a lot more to it than just that. And these are the dangerous parts. These are the parts that I'm like, I've drafted it, I'm done. And then 5 hours later, I'm still working on all of these things, and I didn't know how that happened. But of course, you have the actual object on the plate. But after that, you also have a title block. The title block has a lot of things in it. It should have the show, the name of the director, the scenic designer, technical director, draftsperson, event site, last updated date, scale, sheet number, title of sheet, and any names of any other collaborators that you'd like to put on there. What this means, of course, is the show, so you know what it's doing, the director, scenic designer, technical director, and other designers, so that if anyone needs to contact someone for this particular show, if you have 4 or 5 sets of drafting floating in a scene shop at a given time, how do you know who to talk to if you have a question? When every piece of paper includes all of the collaborators, then it just makes it easier and faster for someone to look somebody up and communicate with them. And that's what we want. Because if you're asking a question about how it's drafted, you can contact the draftsman or the scenic designer. If you notice there's a discrepancy with what the lighting has been planned to do and the scenic plan that is in your hands, you can definitely flag that for them so that the designers can talk about how to remedy that problem before it happens and we're standing in a theater. So it also includes the event site for some similar reasons to make sure all of that is there, and the last updated date. Because if you do update something, which I just said always happens, you need to know when it was updated and what is the most updated piece of paperwork that you have. We also don't update every single plate every time we make an update. So having an updated plate for plate 4, but not having an updated plate for plate 3 is also perfectly acceptable. Scale needs to be on every single title block, and there is some times where you will see scale, every time you see scale, it's represented like it is here. Scale, 1/2 inch equals 1 foot, 1/4 inch, 1 inch, whatever those things are, equals a foot. And sometimes you will see it say scale various. And then next to each piece, you'll have to denote what scale that piece is. That's usually reserved for plates where you are combining both 3 inch equals 1 foot and 1 inch equals 1 foot and some 1/2 inch equals 1 foot on the same page. Whether you're trying to do it to save paper or because you're using different scales to represent the same item, it doesn't really matter. You still have to mark the scale each and every time. The sheet number, because it's important, and the title of that sheet to help people understand what they're looking at. Am I looking at ground plans? Am I looking at side views? Am I looking at elevations? Am I looking at a color map that I didn't know was a thing until you did it? So that really helps us to stay oriented. What do line weights and symbols look like? This is part of your project, but the thickest line is usually an outline. The thinner lines are detailed lines. Dashed lines means thing above or hidden below. And the thinnest lines, the thinnest of thinnest lines are your dimension lines. They're designed to kind of disappear a little bit. You can even see in the scan over here that they're not quite solid. Anytime you have something filled, whether it's filled with gray, filled with white, or filled with hatch, is usually something meaning that is cut through. Open or white is that you can see a surface through that. So thinking back to that windowsill we saw as an example, or any of these doors and windows, when you go through this section, it's a lighter outline than these sections because that is the windowsill that you're seeing or the window pane that you're seeing, where this wall is cut through and it's all cake. So all of these pieces are exactly like we talked about, where thick lines mean a differentiation in plane, and thinner lines usually mean dimensions or something else. Dashed lines mean things that are hidden. So when you're working on making a door, you have the actual structure for the door here, and then you have a reveal that exposes how deep the door is. You denote which direction the door opens, and the dashed line shows the door frame as the door is opening. This convention of how you identify a door, a sliding door, a window, a fireplace, or a chandelier. Like, your chandelier doesn't have to be this shape. You just represent it with a circle and a spoke wheel. It looks a lot like we're driving a ship, but I digress. And you do those things because that's the convention of what they are like, including when you're looking at fabric, you want to make these gentle squiggles with it to show the fullness that fabric uses. If you look at any curtain, it's very tight up at the top, but by the time it gets to the bottom of that curtain, it has widened due to the width of the fabric or the fullness as it goes in and out. Platforms, stairs, and ramp always show their height in a circle from the deck. So the standard for that would be, in this case, plus 12 inches from the deck or plus 30 inches from the deck. Stairs are denoted by having each one of those steps have that increment that step is. So in this case, it's 6 inches from the deck, then 12, then 18, then 24, then 30. An arrow can help to indicate that is a regular step all the way up. So you can go 6, 12, arrow all the way up to your final destination, and then say 30. And if you have a very long staircase, that can help you skip a lot. It's always in inches, and it's always from the stage floor. Anything organic usually is in a detail line weight, something very light, and is usually noted or titled so you know what it is. You don't just make squiggles that look exactly like this and say, oh, someone will know that's shrubs. You still label it shrubs so that everybody knows what it is. And mounds or rocks are helpful in that way too. When you have variation of scale, it's often for preference, right? Like, you're choosing to have a bigger scale in order to see it better. And you're choosing to do what you think is best for somebody else to understand your design. Dimensions are used to clarify the exact measurements that something is, and it's the smallest hairline line weight that there exists in your computer. And you want to specify the structure that you're going for. You want these to be clean and organized, stacked on top of each other. And they do usually help you to see if you want to maybe round your item to a round number. Like, instead of drafting all of your objects at 1 foot 2 1/4, you just make them 1 foot 3 or 1 foot 2. That's your choice as a designer. But rounding those things can often make everyone's lives a little bit easier. You do want your dimensions to be as prolific as possible without muddying everything up. So take advantage of the fact that you don't have to dimension this and this at 1 foot 9, because this one is noted and is the same height as everything else, so that you can have the room to dimension a lot of the weird stuff that's happening. All of the things still have to be in scale, because if you miss a measurement, someone should be able to take a scale ruler, put it on this drawing, and figure it out. But also, there has to be a single dimension on every single plate you print. Even if it's a ground plan, you just need one somewhere on that sheet, because if someone prints it out, they need to be able to check that it is in fact in scale. Sometimes you have this printed on very big plates like this one here. And every single one of these units, I have a little section with notes that specify if there's any materials that I think this should be made out of, if there's any special needs of those pieces, if I think that who is building it needs to know the use, and anything that I recommend or desire for the construction process to have. A lot of the times those things are negotiated and talked about during the budget meetings, and after final designs, where you're planning on how those things are being constructed and built, and we move through them. The labels that we use are a uniform system, And one of the weird things is that we label things always to the below and to the right, the same way that we put the title block in the bottom right-hand corner. So here you can see that the ground plan has these little circles with arrows. Each of them have a letter inside, and that helps to point you toward the rendering. So this one here is for this ground row piece here. This J is for this big wall here. And so the elevations that are provided for those in other places have those markers. For example, the door that is here is G on this side and H on this side. And so the elevation for it says G or H/2, and I have blown that single wall out to the plan view, the front view, the side view, and the section view. So they know exactly how it's built. Then once again, as we've already looked through, if there's a specific type of drawing that you think you need to do or page that you need to do to better communicate, that's what you're going to do. Although this is a codified system, you can make up some of your own codes as long as you have a color-coded key or some way that somebody knows what's happening. Another thing that I often do is create a stage management ground plan with measurements. So I use the stake feature inside Vectorworks to set the center point of the center line and the plaster line at 0, 0. And then each of these items, I can just do one click and drop in the measurements for the stage manager of how they're going to tape the floor on each and every one of those points. This then works as a Cartesian graph where the X, if it's positive, this is 6'8" over this way, whereas if it's negative, this means it's 4'11" from this central point, and Y works the same in either direction. Some stage managers love this, some don't, and it's fine for them not to like it at all. So in class, we're going to talk about how you use a scale ruler and work that out together, and physically use a scale ruler to draw some things and do some exercises. And that is going to be how you do the rest of your project. And that's it for your drafting lecture. Thank you so much, and I'll see you in class.